Somewhere, at some point, a human opened their mouth and said the first real word. No one knows exactly when. No one knows exactly what it sounded like. And here's the strange part. Words don't fossilize. You can dig up a bone. You can dig up a tool. You can't dig up a sentence. So how do scientists even try to answer this question? How do we know anything about the first time a human being actually spoke? Let's dig into one of the strangest mysteries in human history. Here's the core issue right away. Every other part of human evolution leaves evidence behind. Bones, teeth, tools, even footprints sometimes. Speech leaves nothing. No sound wave from 100,000 years ago survived to today. So instead, scientists have to get creative. They look for indirect clues. Genes, bones in the throat, the shape of ancient skulls, anything that hints at whether a person could have spoken, even if we can't hear them. And because the evidence is indirect, the estimates are all over the place. Some researchers say language emerged around 100,000 years ago. Others push the physical building blocks for speech back over 1,000,000 years. It's genuinely one of the most contested timelines in all of human evolution. Let's go through the actual clues one at a time. In the 1990s, scientists studying a British family noticed something strange. Multiple members of this family had serious problems with speech and grammar, generation after generation. It ran in the family, clearly genetic. Researchers eventually traced it to a single gene. They called it FOXP2. It quickly got nicknamed the language gene in the media, which honestly oversold it a little. Here's what's actually true. The human version of FOXP2 is slightly different from the chimpanzee version by just 2 tiny changes. And when scientists pulled DNA out of actual Neanderthal bones, they found Neanderthals had those same human-type changes in FOXP2. That's a big deal. It means this mutation probably showed up before humans and Neanderthals even split into separate groups, in a shared ancestor living somewhere around 300,000 to 400,000 years ago. So does that mean Neanderthals could talk? Maybe, but here's the catch. Later research showed FOXP2 isn't a simple on-off switch for language. It's not you have the gene so you can talk. Language ability seems to depend on tons of genes working together, not just one lucky mutation. So FOXP2 is a real clue, just not the whole answer. Let's talk about a bone you've probably never thought about, the hyoid bone. It's small, U-shaped, sits right in your throat, and it anchors muscles that are critical for producing speech. In 1989, archaeologists found a Neanderthal hyoid bone in a cave in Israel, dated to about 60,000 years old. And when they compared it to a modern human hyoid, it looked almost identical. For a while, scientists got really excited. This looked like solid proof Neanderthals had the physical equipment to speak. But then, more research complicated things. Turns out, hyoid shape alone doesn't tell you as much as people thought. Here's a wild fact. Pig hyoid bones look remarkably similar to human ones too. And pigs obviously do not talk, so shape alone isn't proof. More recently though, scientists went deeper. Instead of just looking at the outside shape of that Neanderthal hyoid, they studied its internal bone structure, how it was built to handle physical stress. And that internal structure looked consistent with the kind of muscle use you'd expect from actual speech. So the case for Neanderthal speech is back on the table. Not proven, but a real live possibility based on real evidence. Now here's where things get really interesting, because there's an actual scientific fight happening over this next point. For decades, the leading theory was about the shape of the throat itself. Human voice boxes sit low in our throats. That drop creates 2 separate connected chambers instead of 1, which lets us produce a huge range of distinct vowel sounds. Way more than other primates can manage. This 2-chamber throat was considered uniquely human, and scientists dated its arrival to right around 200,000 years ago, matching up nicely with the appearance of anatomically modern humans. It even seemed to explain something else. Around that same time, complex modern human behavior starts showing up in the archaeological record. Jewelry, burial rituals, cave art. It all seemed to click into place together. Clean story, right? A low throat appears, speech becomes possible, and suddenly humans start doing complex human things. Except, in 2019, a study blew a hole in that theory. Researchers studied the vocal tracts of a bunch of primates, baboons, macaques, other species that definitely don't have that low human-style throat. And they found these animals could still produce distinct vowel-like acoustic sounds anyway. which means the "you need a low throat for vowels" idea might just be wrong. And if that's wrong, the physical building blocks for producing distinct speech sounds might not be a recent human invention at all. They might trace back tens of millions of years, deep into primate evolution, long before humans existed in any form. That's not a small correction, that's a massive rewrite of the timeline. And right now, scientists are still actively arguing about it. So let's be honest about where this leaves us. There isn't one single agreed upon date for when humans started speaking, because different types of evidence point to wildly different time frames. The physical anatomical ability to make varied vocal sounds? That might stretch back tens of millions of years, way before us. The genetic building blocks, the FOXP2 type mutations? Those trace back at least 300,000 to 400,000 years, into a common ancestor we shared with Neanderthals. Full, complex grammatical language, the kind with structure and abstract ideas? Most researchers place that somewhere in the last 100,000 to 200,000 years, lining up with modern Homo sapiens and a documented explosion of symbolic, cultural behavior. Here's the honest takeaway. Having the raw ability to make sounds is not the same thing as having language. A parrot can make sounds. That's not language. Somewhere between can make a sound and can tell a story, teach a skill, warn about danger with specific words, something enormous happened. And scientists are still trying to pin down exactly when and exactly how that leap occurred. Here's why this question matters so much beyond just curiosity. Once humans could really talk, really communicate in detail, everything sped up. You could teach a skill without physically demonstrating it every single time. You could warn your group about danger from far away, in the dark, without seeing what you were pointing at. You could tell a story about something that happened last year to someone who wasn't even there. That's an enormous advantage. Suddenly, knowledge didn't die with the person who learned it. It could be passed on generation after generation purely through sound. Many researchers link this shift directly to the explosion of complex culture we see starting to show up around 100,000 to 50,000 years ago. Symbolic art, complex tools, organized rituals. Correlation isn't proof, but it's a striking coincidence that's hard to ignore. So, did a single human, at one single dramatic moment, invent the very first word? Almost certainly not. It looks far more like a slow, messy, layered process. Millions of years of physical groundwork in our primate ancestors. Hundreds of thousands of years of genetic tuning, and then, somewhere in the last couple 100,000 years, all of it finally clicked into something we'd recognize as real language. No fossil records the actual moment. No recording exists of the very first sentence. But every single word you've spoken today traces back through that same unbroken million-year chain. It's easy to take talking for granted. It's one of the strangest, most powerful tools our species has ever developed. If this made you think differently about something as simple as opening your mouth to speak, subscribe, because I dig into the strangest, most human moments buried in our deep past every single week.